The title of today's paper is, Interference of Manganese Removal by Biologically-Mediated Reductive Release of Manganese from MnOx's Coated Filtration Media, published in the Water Research X, in 2018. Discontinuing application of pre-filter chlorine is a common water treatment plant practice to permit a bioactive filtration process for the removal of soluble Mn. However, soluble Mn desorption has sometimes been observed following cessation of chlorine addition, where filter effluent Mn concentration exceeds the influent Mn concentration. In this paper it is hypothesized that Mn-reducing bacteria present in a biofilm on the filter media may be a factor in this Mn release phenomenon. The primary objective of this research was to assess the role of Mn-reducing microorganisms in the release of soluble Mn from MnOx's coated filter media following interruption of pre-filtration chlorination. Bench-scale filter column studies were inoculated with Shewanella oneidensis MR-1 to investigate the impacts of a known Mn-reducing bacterium on release of soluble Mn from MnOx's coatings. In situ vial assays were developed to gain insight into the impacts of MnOx's age on bioavailability to Mn-reducing microorganisms, and a quantitative polymerase chain reaction (qPCR) method was developed to quantify gene copies of the MTRB gene, which is involved in Mn reduction. Results demonstrated that microbially-mediated Mn release was possible above a threshold equivalent of 2 × 102 s oneidensis MR-1 CFU per gram of MnOx's coated media, and that those organisms contributed to Mn desorption and release. Further, detectable MTRB gene copies were associated with observed Mn desorption. Lastly, MnOx's age appeared to play a role in Mn reduction and subsequent release, where MnOx's solids of greater age indicated lower bioavailability. These findings can help inform means of preventing soluble Mn release from drinking water treatment plant filters.